I better press the lock first, just in case that open. You did remember my story. Yeah,
only realize
crazy. And that was one of the other things that I put on my but it, I understood. Even though I press record, I still like, where's your hand away? So early, yeah. Never thought.
actually that results for heavy response. There was one question in section that who by myself. You third because I thought it was giant communal like like some of everything is not very stuff. This it's a diagram of about routing part of each one to that there's so that was giant.
Oh,
Yeah, right.
gonna check this. Oh, I think
Then it then that stop. Then another our giant because we didn't do it
when you
carry on don't have some
have too many income.
yeah.
By the way, B.
Right.
But you're not actually class. Yeah, I have not that many revision and jail workouts here. But you are very last week, last week.
Last week would be
Last week, Monday, let's pick 5. That's super early for second change next year. But the camp have any revision is definitely. Doesn't make a difference. Really, 1 year.
that really one for like all of this.
We can kind of thing. If you have a job on that, I'm going to be meeting. Let me go. There's supposed to be 7 people. Yeah. 9 plus goes back. 20 plus. How many do I have currently? Oh, okay, not bad. 282401. So interesting. Ask you first. Early down. Because it's not kinematics inside which you can revise on knowledge. And the section physics. Okay, you're not set 4. Okay, hello, welcome. Which school are you from? Oh, I'm a star. Right near my house. What's your name? Jody. Okay. Okay, now. Finish it. Oh, okay. And what you do? I do it all. Giờ phải là thế. This is what I want. How I get. Nên là what theo nó là một con. That long after that. My brother's house very near. Wow, this is crazy. First school like near my house, first school like near my brother's house. Okay, can see at the back. Yeah. Confirm? Okay. Go make sure you can see the W actually. Yeah. Where is the W? I don't know. Yeah. Alright, and I don't know nice news now. Oh, here it is. It's all one. Okay. Okay. So today's 1.1. You are to be honest, so both ways really, my I have learned mechanics. Okay, that's strange. Okay, what 7:31 already. Hello people, thanks for joining online. I have 7 of you. And who is Clarence student? Is it your Clarence student? Oh, okay. Yeah, he's A net student. Okay. Yeah. Because he just told me that you are coming. Okay. Then welcome, welcome. Okay, I press record already. Okay, I'm gonna start with this. Okay, I'm gonna pin myself, okay? So that everybody can see my face giving. Okay, I think especially for people joining online, I will be passing you, I'll be showing you a QR code soon for you to scan and download the notes together with the answer key if you really want to. Okay, but let me start by introducing myself a little. I just find that it will be always weird if you don't know my name for 2 hours and you just listen for the whole 2 hours. Okay, it won't be a 20-minute sharing of myself, don't worry. Okay, because I don't have that many things to share about myself. Actually, I don't want to share too much today. Okay, but I think first things first, uh, I respect your time the most. Yeah, I know students are crazy. Sec 3, you have 8 to 9 subjects to take. Okay, so the fact that you are here means that you are trying to take charge of your own learning. So I seriously thank you for that. Okay, so these 2 hours is, I guarantee you, going to be the best learning experience. Going to be more than what we have learned in school for how many terms? 1 term plus for almost two terms already. Okay, I know sec 3 going is blah blah and like mong, you walk in, you're not sure of anything, you are trying your best to like stay afloat, like already drowning already. Okay, so this is what I experienced in sec 3. So I am here to try to make life a bit easier for you. Okay, so but seriously, my point is thanks for being here. Okay, so a little bit about myself. My name is Gerald. Okay, so I am chem and physics tutor. So I'm sure you all take chemistry. Okay, I think there's no more physics slash bio students anymore. Uh, the EOY revision kit, I'm not sure whether you all attended the Sec 2 EOY revision this year. I only know Elise attended last year. Okay, but Sec 2 EOY last year, I also conducted the EOY last year, and I encourage people to take chem and physics. Okay, so I'm like quite happy that you guys are taking physics if you were here last year. Okay, anyway, I have taught for about 9 years now, and more than 95% get at least a B3 at O levels. Okay, some of my students are here. Okay, this is from last year's students. This year students haven't taken much photo with them yet. Okay, but apart from teaching, like I'm not a robot. Not every day like I come here and teach, then I go. Okay, so apart from teaching, I also play floorball since secondary school days. Wait, am I sharing this screen? Yes, I am. Paranoid. Okay, I played floorball, competitive floorball since secondary school days. And I was an ex-buster of singing on the streets. Okay, I don't know whether I played this video before for people who attended last year, but this is a video that nobody asked for. Okay, so here goes. Okay, those who stay at Ang Mo Kio don't know whether you all like see me before or something. Eh, wow, shit, cannot. Eh, eh, wow, sian. Oh, can. We can come back to learn physics by showing me singing. You don't know this song. Okay, cringe. Okay, anyway, that's just a sneak preview of what I do, or rather what I used to do a little bit. Okay, anyway, I'm a doing Shen Chinese TikTok song fan as well. Okay, and I'm a football fan. Love Asian food as well, and I love Indian cuisine too. Okay, and a little bit of a new addition to me. I am currently grooming a 3-month-old to be a human currently. So this is the 3-month-old that's trying to be a human. Okay, so I can't wait for her to be like you guys soon. Okay. Okay, anyway, we are gonna get the ball rolling today. Especially for online students, if you have not downloaded the worksheet yet, here is the QR for you to scan the worksheet. Okay, for people who are here physically with me today, I have the physical copy for you. The answer key I will print for y'all, so don't be too obsessed with copying down the answers. For physics, I feel there's no way for you to like cram everything one shot at the very end. Okay, there is some value in you learning things that like how can I approach a possible question that may come up tomorrow. Of course, you have to seriously tomorrow. Tomorrow. Okay, so the exact same question won't come up, but I feel the similar approach will definitely come up. Because there are only a few ways that you can ask certain questions. Okay, so here is the worksheet for you to download. This is a need for online students because this will allow you to follow much more easier. Okay, if not, we will begin now. Okay, we don't have a lot of time. I will give you a mandatory break like halfway through. Okay, but I will try my best to not overrun. Okay, that's my usual thing that happens. Okay, just a brief overview of what's going to happen today, right? For those who are tested for kinematics, we will not be running through kinematics. The three topics that we'll be focusing on today will be dynamics, turning effects of forces, and pressure. Okay, I don't know whether you have been tested or rather you have learned this in school already or not. I suspect most of you should have learned dynamics and turning effects. Okay, but some schools I know are a bit special. You all start with thermophysics, right? Then you went on to waves already. Okay, so different schools are a bit different. Okay, but I think this mechanics is one of the hardest thing to master. So if your teacher didn't start with that, I suspect your teacher not very sure. Okay, I don't know. Okay, so this mechanics is seriously one of the topics that students always die in set for. Okay, this dynamics topic I feel is the hardest to grasp. Okay, but if you know how the questions are being asked, you will be good. Okay, I will go through the content a little first. You will be able to try some questions. I will tell you exactly how to dissect the questions and break down whatever question that you will face in the future. Then we will discuss the question together. Okay, first things first. I know the first page here on page 21 is super wordy. Okay, mass and weight, Newton's first, second, third law all jump inside this one page. Why we choose to do that is for you to have a one glance. Okay, but what I need you to focus on will be a few things. Okay, number one, you take height and weight in school, it's all fake. Why? Because you are always taking your height. Okay, because you are always reporting them in kilograms. The key thing that will happen during your exam that I can predict is this one. Okay, question will try to play trick on you by giving you in grams. Okay, so take note that the SI unit, the standard unit, that whatever formula that you will apply, you need to put them in kilograms. Okay, I think the famous one that you probably use quite a number of times already will be W equals to mg, weight equals to mass times g. G being 10. G can be 10 meter per second squared. G can also be 10 Newton per kg. Don't be too alarmed if they give you in different units here. It's in fact okay. Okay. SI unit for mass is kg. SI unit for weight is going to be in newtons. Okay. And key thing to note is mass does not change. Mass is constant. Therefore, if they give you another planet, mass is still constant. Hello? Sec 3 physics? Sec 3 physics? Sec 3 physics? Hi. Okay. MPX. All written in the fluid model tools. Hello. Anyway, short intro of myself, my name is Jerome. Because I did a short intro of myself during the first few minutes. Okay, but we are currently on page 21 of the notes that I passed to you. We are focusing on dynamics chapter first. Okay, so these are things that can potentially be tested when they bring you to another planet. Okay, if they bring you to another planet, you need to know that mass is going to be constant. Another planet also constant. Okay, because when they bring you to another planet, the thing that's going to change will be G. The thing that doesn't change is your mass. The thing that can change will be your weight. Okay, because G changes, weight is going to change for sure. Okay, and that's what I need you to know for mass and weight. That's about it. Okay, the three big laws, first, second, third law. Do you need to hardcore memorize the entire thing? If your school is going to do so, right? Stop doing it. Okay, there's no way that your exam paper will say define Newton's first law. Never. Okay, because the syllabus has already highlighted that stating of the law is not required. But do you need to apply the law? Definitely yes. Okay. So Newton's first law of motion, you don't need to be able to state, but when you explain in terms of the law, you need to be able to tell me that an object will continue in its state, either at rest or constant speed, unless resultant force. Okay. In short, Newton's first law can always be understood as inertia. Okay. Inertia needs to be understood as when you take the MRT train. What happens? You always feel yourself jerk forward, jerk backwards. Usually, you see people who fall forward, fall backward are people who has a lot of mass. The only thing that affects inertia, question can throw a lot of curveballs at you. Does density affect inertia? Does volume affect inertia? Nothing affects inertia except for mass. This is the this is the this is the only factor. What's the name? Yeah, I refresh. Mass is the only factor that affects inertia, nothing else. Okay, so personally, I think you can probably guess that my mass is like relatively higher. Okay, so I have personally flown half a bus before because of inertia. Okay, so when the bus started moving, then I moved. Okay, so it only depends on the mass. This is important. Okay, so whatever the question throw at you, only the mass will affect, nothing else. So that's good. Second law of motion. This is the one that is used a lot of times for calculations and for a lot of things. What I need you to know for sure is if your school teacher do F equal to MA, like what the note is writing here, right? Throw it away. Okay, huh? Then I throw away like one month of knowledge, is it? Okay, it's not throw away 1 month of knowledge, but usually people don't know what the F is because they learn just F equal to MA, F equal to MA. Okay, so throw it away. If you are still using F equal to MA, I want you to use R. Okay, in your head, you probably already know what R stands for because you have learned this topic quite well in school, right? Okay, R stands for resultant. Okay, so it's not just force because there will be a lot of forces acting on the same object. You need to make sure you take into account every single force. Then that resultant force is that force that you are using this. Okay, so things to take note of. This mass, remember to put the SI units as well. So this one must be in kilograms. Acceleration must be in SI units as well. In kinematics, you should have learned this before. ms minus 2 meter per second squared. Okay, so this is Newton's second law of motion. We will be able to apply this for sure. Okay, but what I need you to keep in mind definitely is whenever I apply this formula, remember to consider all the forces first. Newton's third law. Newton's third law sounds very like cheap and everything. How they usually test is I give you two forces and ask you to predict whether it is action reaction pair. Easiest way to understand this without all these words here, right, is A on D, B on A. Okay, and the best way to learn this, if you have someone you hate in school, you give the person a punch. Why? Usually it's very hard to get into fights. You get into fights, so usually you see people like getting bruises on the face and all over. Why? Because of this. The harder you punch someone, the more pain you are going to feel because of Newton's third law. Okay? But the key thing for this part is you need to make sure this is it. They must be acting on different bodies. The trick that usually question will use is whether weight and normal reaction force are action-reaction pair. For example, you have all your notes or your books on the table. I put my book on my table. My book has a weight. Whenever we stand on the floor, we know that there's a normal reaction force acting upwards. I place the book on the table, no different. I have a normal reaction force acting upwards. Common question will ask you, hey, is this action-reaction pair? Most of your classmates are going to say, yeah, because different direction, therefore action-reaction pair. Okay, is this true or not? Not true. Okay, so this may be a bit surprising, okay, but if you relate it back to the yellow highlight that we just did, on B and on A, is this going to be action-reaction? It's actually not. Because the orange color, the normal reaction, is stable on book. The blue color, the weight, is actually Earth acting a force on the book. Can you see where I'm going already? They are both acting on the same object, therefore, they are not action reaction. Then comes the question, then what on earth is the action reaction pair? Right? Okay, so we are all getting put by earth to the center of the earth in a sense. Okay, so are we exerting a force back on earth? Actually, we are. So the action reaction pair to weight, right, is actually a force of the book on earth. This is then the action reaction pair. We are all exerting a force back on earth, but can earth feel it? Earth doesn't feel it because the earth is too gigantic to feel anything. Okay? But usually when they ask for the action reaction, this is it. That's good. Okay. I want to cut down on the things that I said. I know you are very eager to try the questions already. Okay, go on. Last two parts. The vector addition, I won't spend too long. Okay, but I need you to know the two methods that you can potentially apply. If your school doesn't teach parallelogram, it's fine. If you use the triangle method for all possible questions, it's fine. My word of recommendation is use the triangle method if forces are all in equilibrium, meaning they will all cancel each other out in that sense. And when forces are in equilibrium, remember that you form an infinite loop. What do I mean by infinite loop? The direction that they point towards is always forming a loop that chases itself again and again and again and again. Okay, so the direction is always important for vector diagram. Okay, I like to call this the Tom and Jerry. If you all still watch, Tom and Jerry like to chase each other. Non-stop throughout the whole episode, they just chase each other. At the end, then they become friends. Okay, so they just keep chasing each other. Second, situation where you can apply this, right, is forces don't originate from same point. This is the second possible situation where you can use this. What do I mean by this? In the diagram over here, right? The force started from here for the U. The force started from here for the T. They don't start from the same point. I recommend you to use triangle. If they start from the same point, like in the second diagram here, right? Both forces started from this blue color point, U and V. Then I use parallel to help. So the condition for this I recommend is forces start from same points or originate from the same points. When forces start from the same point, use parallelogram. Something for you to amend a little, okay, that the diagram may be a little bit misleading for you. When you draw the parallelogram, use dotted line to complete the parallelogram. And when you are trying to find the resultant force is always double arrow head. Word of caution, when you use triangle method, when you are putting everything in equilibrium, make sure no double arrow head. Because you are not finding a resultant force, that's why there will be no double. Okay, so this is a quick one for vector addition. Okay, there will be a question later. I will tell you exactly what examiners to look out for when you draw. Okay, but I won't have enough time for you to draw. Okay, but we will highlight exactly what we need. Last two portions. Friction. In 1 minute, I need to make sure that you are aligned with me on this. Okay. Friction, the biggest thing that questions like to ask is in which direction is the friction acting? Okay. And the hardest part to this is when a tire is moving, sometimes my teacher say backwards, sometimes my teacher say forward. Like what the heck, right? Like which one is which? Okay. So take note that traction, this word traction, traction here. Traction equals to useful friction. Therefore, traction is to allow us to move forward. Okay? So whenever we are walking, we are generating traction. Therefore, friction is trying to move us forward. Friction will act in the same direction as where we are moving. Okay? So example number one, when we walk, friction is always acting in the same direction. Example number 2, tire, vehicle. I need you to be very clear on this because there are two situations for this. Number 1, if this tire is connected to engine, this is super important. If it's connected to engine, then the friction will be in the same direction. The second situation, obviously, you will know, right? If not connected, to engine, friction will be in opposite direction. This is the key difference. So you can imagine, for Singapore car, the one that's connected to engine is usually the front tire. So the tire that is not connected to engine, you can imagine it as being dragged along. Like if I drag the wheel along, the friction is going to oppose that drag. Okay, so if it's not connected to the engine, friction will be in opposite direction of motion. That's all. Last one. And this is the key one that I think a lot of people are super scared of. Okay, I want to spend this 2 to 3 minutes. I need to borrow your next 2 to 3 minutes to clear this down. Okay, because sometimes teachers spend 2 to 3 lessons on this without students really understanding. The key thing to this is number 1. Whenever you're trying to solve questions like this, ask yourself, when I run to the bus stop, wow, the bus coming, I take 102 to whatever. Okay, then versus you walk to the bus stop, which one do you feel more air like hitting your face? Running, right? It's not kind of makes sense, right? Okay, and what is this air that's hitting your face? Air resistance. Okay, so the faster you run, you feel more air hitting your face. This is exactly what I need to be able to apply. Why? Because the key phrase that questions want you to write in your answer is air resistance increase when speed increases. Higher the speed, higher the air resistance. Okay, so this is usually the one that question wants. Something to keep at the back of your mind is surface area. This one, I don't need to explain too much, I feel, because if you all watch people run, right, do people run like that? Like 100-meter race, you see people run 100-meter race like that. No one. Okay, because this will be having super a lot of air resistance because of a big surface area. Okay, so surface area, I'm not so concerned. The speed one is what we need to be able to apply. Terminal velocity. Okay, this is a tricky one. Okay, and exactly what questions require you to write, I need to tell you exactly. If we take a parachutist jumping for an example, okay, or before even this parachutist jumps, okay, if you imagine yourself with your best friend, hold hand in hand, top of a building, jump down together. Okay, but don't do that first. Okay, but if you really do that, right, you need to know that your initial acceleration for both of you, no matter what your mass is, you may be lighter than your friend may be lighter than you. Your initial acceleration is always 10. Initial. Okay, so at the very, very, very start, both of you are going to experience 10. That's why this initial acceleration here is 10 meters per second squared, no matter what it is. Okay. Sorry, I'm a bit morbid, right? Okay, so don't do that. If terminal velocity, therefore, you need to understand it as I need to be able to draw the free body diagram here. If I draw a free body diagram, if I call this the parachutist, right? If when a parachutist jumps, the thing that is going to act on it is going to be weight. The weight is going to act downwards. Okay, so that's why it is getting pulled down with an acceleration of 10 meters per second squared. The velocity of the parachutist is going to increase for sure. As my velocity increases, what happens? Then you need to tell yourself, I run to the bus stop, I feel more air hitting my face. What's up next? With velocity increasing, air resistance increases. Okay, so this is the next key part that questions require you to write. Okay, so understand it in the form of a diagram first. I will get to the words very soon. Okay, but what happens is, as my velocity increases, my air resistance starts to increase. This is the key part already. Okay, how do I calculate resultant force from this? Resultant force must be calculated using my weight that's pulling me down minus air resistance. 。 make the logic very clear here so that you no longer need to study or memorize this. Okay. As a student, after I recognize this, I no longer look at the speech in my notes or in the textbook. Okay, because I understand exactly how it works with. And resistance start to increase. What happens to resultant force? Decrease. Because my weight doesn't change. What is it going to increase until and resistance continue to increase because my speed is keep increasing and increasing and increasing until a point where weight equals to air resistance. Weight equals to air resistance, resultant force, 0. Acceleration, 0. This, people, is terminal velocity. That if you understood in these last 3 minutes what we were discussing, you no longer have to refer back to the speech. Okay? You will only refer back if you somehow forgot the keywords a little bit. Okay, keywords on top, I tell you exactly what examiners or marking schemes are always giving marks for, or always minus marks for. Number one, you need to tell the examiner velocity increase, air resistance decrease. For sure. Okay, until which point that we discussed, air resistance equal to weight. Air resistance equal to weight, then RF equals to 0, 0 acceleration. Because RF equals to MA. Again, apply RF equals to MA at this portion. Therefore, I reach terminal velocity. Okay, so there's nothing much to this anymore, because if you understood it, you'll be good. Okay, and we are going to solve some questions very, very soon. Okay, allow me to just run you through this graph a little bit for the benefit of people who have kinematics as well. Okay, so just a short one for kinematics people. Kinematics, you will have a velocity time graph tested tomorrow or whatever your W is coming, for sure. Okay, velocity time graph, first thing to tell yourself for kinematics always is, question yourself, what does the gradient represent to me? Velocity time gradient represents the acceleration. That's all I will talk about for kinematics for now. Okay, but if you have questioned yourself this already, what you can see will be the following. The gradient initially was steep. What happened to the gradient as I move along? It gets gentler and gentler and gentler. Why does this occur? Whatever we have discussed. Because RF is getting smaller and smaller and smaller. Therefore, my acceleration gets smaller and smaller until 0. This is then my terminal velocity. The flat terminal velocity, gradient is 0, therefore acceleration is. Parachute open, exactly what happens here. Sometimes question will throw this in here where parachutist opens the parachute. This is when surface area comes in. Surface area, very large. Air resistance, more than weight. Resultant force, upwards. Deceleration. Okay, so this completes the loop again. Okay. I think some of you are able to connect the dots here already. Okay, but to complete the loop of the entire graph before you try some questions, right? After it decelerates, what happens? As I slow down, less air molecules hit my face. Air resistance drops. Air resistance decrease until weight equals to air resistance. Again, this leads to RF equals to 0, acceleration 0. That's why I reach a second terminal velocity. Okay, I hope this makes terminal velocity super clear so that you potentially don't need to refer to this anymore. All the way until set 4. Okay, set 4 confirm you're like, okay, I need to revise a little because I did too much playing set 3. Okay, so that's it for dynamics. Okay, I think I took longer than I was supposed to. Okay, but I'm here for you to try. Next part will be for you to try some questions. Okay, we shall not let you try. Let you try 1 to 5. Then sure we become 1 to 5. We go question by question. Dissect a little for yourself before we go into this. Okay, so question 1. I shall not dissect anything here. Yeah, I block the answer intentionally as well. You can give it a shot in about 30 seconds. Okay. Usually in my class, my 30 seconds becomes 3 minutes, but today will be quite strict. Okay, if not we'll overrun question. Okay, so 30 seconds for you to give this a shot. See what answer you can come up with. 10 seconds, right? Yeah. I won't individually ask you for your answer. Okay, but we will dissect the question together on potentially if the question is a similar thing like this, what you need to take note of. Different mass for sure. When two objects have different mass, they are going to have different terminal velocity. Okay? Different mass, different terminal velocity if I fall from a very, very big height. Okay, so this is one of the things that in the previous page, I essentially did not say first. If I say already, you all can do this question. So I want to link this back soon. Okay, but with different mass, I see that R reaches the ground first. R reaches the ground first, link this immediately to R is heavier. R has higher terminal velocity. Okay, which I want to link back to the pro tip that was in your notes here. The last pro tip for the notes here is different mass, same initial acceleration like we were saying, but heavier, higher terminal velocity. Okay, and understand this for a fact. Why higher terminal velocity? With a larger weight, it is harder for the air resistance to become equal to the weight. That's why it can accelerate longer and become a higher velocity. Okay, so higher or heavier object always has higher terminal velocity. That's why if you chose not true, small amount. If you chose B for this question, the answer will not be correct because S indeed is lighter. Okay, I review the answer first because some of you may have gotten this correct. Answer should be A. They accelerate at constant rate but with different magnitude. Is this true? Nope. It's not constant rate, it's only at the initial acceleration is 10. But as it falls down further and further, with different mass, they will have different amount of air resistance acting on them. R is going to have a higher terminal velocity, so they do not accelerate at a constant rate. So linking this to the graph, right? This is definitely not a constant acceleration because it gets gentler and gentler and gentler. So both of them shouldn't have constant acceleration, but decreasing acceleration. Both R and S must have decreasing acceleration. Okay, I'm going on. Question 2 is one of the questions that I feel will come up for your WA. Whether or not they give you 1 card, 2 card, 3 card, 4 cards. I give you some tips for this question first because I feel if I throw you into this, you probably won't solve anything. Okay, things to look out for in questions like this is sometimes question can give you 2 boxes. I tie 1 string in the middle. I pull the whole thing along. Whenever question gives you this kind of things, take note that on MRT train, if you are on carriage number 1, your friend is on carriage number 5, do you all accelerate differently as the MRT moves? No. You all accelerate the same now. Ding dong, you reach I am Wangkok now. Cannot be, shit, why I Hougang now already? Okay, if you are on the same train, it's not possible. Okay, so things to take note of for questions like this is all the cards over here or the boxes over here, acceleration, always same. Acceleration of each of the cards is always the same. Okay, and the next thing to know is the following. This string over here pulls card, pull card 1 to 4. This string over here pulls cards 2 to 3, 2 to 4. This string over here pull cards 3 to 4. This string over here pull cards 4. Get the logic? Okay, so whenever they tie a string in the middle, tell yourself this first. Okay, like I think the questions like question like this, apply RF equals to MA no matter what you do. 1 minute exactly to solve this question. Okay, give this a shot no matter whether you could solve it or could not solve it. I think it's very important for you to think it through. Okay, 1 minute, let's go. Try. This question is easier than you think. If you know the logic behind all the green words that we have written, you should be able to solve. That 20 seconds left. And I have to answer already. Yeah. 10 seconds. This is the only calculation question in the MCQ. So I need you to get this once and for all. Correct answer, revealing, should be C. 2,400 newtons. Who got correct? Wow, very good. Okay, so you all understand the logic behind this already. Okay, so whenever question wants to test you this, if I'm testing this tension over here, first thing to tell yourself, what is it pulling? I'm pulling 2, 3, and 4. What's the combined mass of 2, 3, and 4? Each of it has 400 kilograms. 400, 400, 400. In total, my mass equals to 1,200 kilograms. I'm pulling 1,200 kilograms along. Each of them accelerate at 2 meters per second squared. RF equals to MA 2 times, 1,200 times 2, I should get 2,400 newtons. Okay, so I would say this is sort of an easier question already in your WA. Question may not give you the acceleration of the entire system. So what you can do for a start, you can go and find out the acceleration first by considering the entire system. Okay, I want to spend 1 minute to give you an extension to this question, even if you got this correct. Okay, because question may not give you this 2 meters per second squared, and that's when some of you may die. Okay, so if question does do that to you, right, consider the entire system as one whole thing, orange color thing. Question may tell you, I am having, I don't know, an elephant pull this entire thing along with a force of 24,000 newtons, for example. If question does give you this, can you calculate the acceleration of every single part? Can. because you consider the entire system, the resultant force is 24,000 newtons. The mass is 200 plus 400 plus 400 plus 100 plus 100. You can calculate acceleration. Okay, so question may not be so nice to give you this 2 meter per second square. That's what I mean. Okay, so if question does give you that, use 24,000, divide by the total mass first, calculate the acceleration for each of them. In your head should be, oh, acceleration always same. So then I can zoom into a particular that I want to consider. In this case, the blue color portions. Okay. Okay, this is the question that I want to spend most time in. Okay, for question 3, I just give you 30 seconds for you to think about. Okay, I want to go on to the structured question soon. Okay, question 3 is very worthy to think about. Remember, A on B, B on A. See whether you can solve this. Ten seconds to wrap up. Good side. Okay. Answer to this question is D. You get this? Okay, if you understood A on B, B on A, I don't need to explain too much. Give me 10 seconds for this. Okay. Answer is D because P and S. P and S is on the man, parachute on man, man on parachute. Okay, so for those who chose Q and R, note that they are acting, it's not A on B, B on A, even if they are acting on different objects. Remember, I need A on B, B on A. Okay. Question 4 and 5, you can try them together. We will discuss in approximately 1 minute. Okay, so 30 seconds for each. Should be more than enough with no calculations. I want to move you on to some calculation questions after this. Thirty seconds. And time. Okay. Whether or not you have finished, I think the most important thing is you have thought through them. Okay, I read you the answer for those who have finished first. Answer should be CC. Okay, if you have gotten both correct, great. Okay, but further think about a few things that we will extend a little for the questions. Okay, for question 4, answer is C. And I think if you understood what we said about terminal velocity, this should make sense to you. Okay, why does it reach terminal velocity? Because air resistance keep increasing as my velocity becomes larger and larger, larger and larger. Until resultant force 0, acceleration 0. Therefore, answer C. Okay, question asked without opening his parachute. If question gives you a bit further, like, oh, what if he opens his parachute? Potentially the question may change. Okay, why does it reach terminal velocity? There will be 2 terminal velocities to reach if he opens the parachute. Okay, so just take note of if question extends this for you, go back to the graph that we have just discussed. There will be 2 lines on the graph that are flat, because that's where terminal velocity occurs. Okay, so question 4 is not so difficult. Question 5, C as well. What I need to take note of is more of things you can pick up in the question, empty space. Other things that question will say, no air. The question says things like that. No air, empty space, ignore air resistance. All of this suggests to you that air resistance is negligible. If there's no air resistance, when a spacecraft goes into it, initially engine powering it forward, if this is the ugly drawing of my spacecraft, that's rectangle and triangle. Okay. Forces acting on it is, initially I have the engine force. Engine is trying to push it forward. Because I'm traveling in empty space, there is no air resistance. The moment my engine switches off, what happens? This happens on. Nothing else acts on it. No air resistance, no engine force. It should continue to move with constant velocity. That's the MCQs. Okay, question 6, unfortunately, I would love to have you draw this, okay, but I did not allocate time for this, okay, because I want you to take note of key things that examiners look out for and some tips that I will give to you. Okay, but in your head, minimally, I need you to come up with the sketch of this before we discuss the answer. Okay, in 30 seconds, look through the question a little, identify how you will look or how your diagram is going to look like via a sketch. Before you draw skilled weather diagram, always have a sketch in mind first. Okay, the last thing I want is you start to erase, then you start to panic, then your paper start to get wet. Right? Just start to crash. Okay, so have a sketch in your head. See how it goes first. Then second step, try to have a sketch. Okay, don't need to be accurate at all, but agak-agak how will your skilled weather diagram look? Which method will you opt for? Triangle or what? Okay, in your head, if you had parallelogram as a potential option, you won't be marked. You need to remember certain things that you need to do. Okay, but for my advice, just now we are saying if it's in equilibrium, you should take it, you should use triangle method. And how do I identify this to be in equilibrium? When all the forces are trying to keep the man or the motorboat here at the constant, trying to move it at constant speed, there is zero acceleration. Key things to pick up from the question, constant speed. Constant speed suggests to you that acceleration is zero, therefore resultant force is zero. This tells you that the entire thing is in equilibrium. That's why my advice is go for a triangle method. Okay, but I will show you exactly how parallelogram sketch can work as well. Okay, potentially in a structured question, they may ask, hey, how come the resultant force must be zero? What can you think about for this? Whatever we have just discussed will be the keywords. Okay, don't be too obsessed with the answer. The answer key will be given to you at the end of this. Okay, in fact, the QR code is already up. Reason why I didn't give you yet, I have it ready. Okay, because I don't want you to be like, oh, answer key here, look, answer key here, look. Okay, so don't bother about answer key for now. Okay, rather understand what we are trying to go through. Yes. Possible to do head to tail even if it's not included. Possible. That's definitely possible. So there are two scenarios, right? And now we say for head to tail. Okay, when forces don't originate from same point, I recommend you to do head to tail as well. So perfectly possible, even if it's not included. Okay. So resultant force, why must be zero? Because we have just talked about this. Constant speed, therefore no acceleration. Newton's second law, resultant force, zero. Keywords here. Constant speed, zero acceleration. Resultant force, zero. Quote Newton's second law, Rf equals to mass times acceleration. Okay, so Don't need to be obsessed with the answer. If you can recognize these yellow color parts, these are the notes that I recommend you to take. Not the exact phrasing, but not important. Okay, but the yellow color one, very important. Okay, so how exactly will your sketch roughly look like? With these forces over here, they are in equilibrium. Okay, the difficult part to this is, it seems to me that the forces are like on the same point. Then how? How can I shift my forces effectively so that everything will look very nice in an infinite loop? Because in equilibrium, my head should be, I must draw to be infinite loop. Okay, so head to tail, as the name suggests to you, right, must be head to tail. They cannot look like this. Forces cannot look like this. Why? Because they are not joining head to tail. I'm joining tail to tail. So head to tail means the forces sort of like chase each other. So with the weight weighing downwards here, I need to shift this force so that it is somewhere here. Okay, so I shift this force so that the tip joins to the tail. From this, the way to check is, I have a drag force D that's supposed to point that direction. When I complete my infinite loop indeed completes in this direction. Okay, so this should be a rough sketch of your triangle. Okay. Things that examiners will mark for when you draw your diagram. Okay, did you label the forces with their respective magnitude? Okay, magnitude meaning should you be labeling cm or newtons? Always newtons. So whenever you draw this, 0.70 kilonewtons, 1,200 newtons. Always label the magnitude of the force itself. Don't tell the examiner the cm. Examiner will measure himself or herself. Okay, then this will be your drag force D. Should this be double arrowhead or single? Definitely single, because equilibrium. Sorry? How do you? Correct. So I will address this in the next part when I go on to the next page. You are absolutely right that the resultant force is supposed to be pointing this way down. Okay? So for those who are thinking about resultant force, you are not wrong. What I want you to take away today, right, is this. Resultant force of this force and this force is going to be this way. If you draw this double arrowhead, correct. You use parallelogram method, correct. What you need to tell the examiner is the resultant force is this, but the drag force is dragging it in the opposite direction in order to keep the whole thing in equilibrium. What I want you to take away is the following. I can look at resultant force, but when I consider the drag force is actually opposing this resultant force. They must be equal in magnitude, opposite in direction. Which triangle? This triangle that we do. So this one, the two forces are acting from the same point. So I basically shift the. Sorry? All three, you can think of it as all three in the same point, but then I cannot be drawing like all three like pointing up in the same direction from the same point because I cannot find any resultant force. Okay, so what I did was here, the drag force, I don't know the length of it. So what I did is I shifted this further downwards. 1,200 newtons, I shifted it here. My weight still stayed here. After shifting it downwards, I complete the triangle using the last drag force. Therefore, it pointed this direction to complete the infinite. How do I know where to put it? Meaning the drag force or the other one? Or this pink color? The pink color, right? The pink color one, you are simply joining the tip to tail. So after I draw the weight up, then I can shift the pink color one down so that the tail joins to this tip. You get the idea? Now, The method called tip to tail, right? The whole purpose of it is I shift the forces so that they are joining the arrowhead joined to the tail. So what am I trying to do, right? Maybe I'll show you another diagram, you'll be able to see this a bit better. If I have this on, and I have this, after I shift this down, can I find the resultant force from this two? Actually, I can also. So if you are trying to find resultant force, this works as well. The resultant force actually acts this way. So if you like, how do you get the triangle in the first place, right? The triangle always comes from the fact after you shift one of the forces. Okay? So if I shift the other force, if your idea is sure, why you shift this pink color one? Can I shift the weight? I can. 1,200 newtons here. How can I shift the weight so that it touches tip to tail? Here. What did I do? I shift the weight to this point instead of originating from the same point. Do I still get the same drag force? Absolutely. To complete the infinite loop, I do this as well. This one is I want to find resultant force. For the purpose of this question, let's ignore this. Which one? The 0.7? Can. This is what I did. Okay, I go through this for the last one already. If not, I will catch you up at 9:30 p.m. instead. Okay, so with this 0.7, I shifted this further down here. So there are two methods for you to shift. Number one, I shifted the pink color one. Number two, I shifted the blue color. This is how tip can look. Okay, if you are still unsure about the triangle, I catch you up a bit later. Okay, for the things that examiners mark for, this, no matter what you do, write the scale. If you don't write, examiner will never give you full marks. Sometimes the scale can even be awarded one, even if you never join. Okay? So be super careful about this. This time I already asked you already. So the forces, the newtons is what you need to write. Don't write cm. As well, label your angles clearly. Whatever angles that are given in the question, put them in. Okay? Anything wrong with this answer? Yes. I don't want this to be pointing this way. I don't want to find the resultant force. Instead, think about the drag force that completes the infinite. Okay, so for this portion, make it straight. Sorry. This arrow should point diagonally upwards. Correct. Upwards. This way. Okay, for the drag force. For this question, the marker or the setter solve for the resultant force first. Kind of like what you did. Right? You're asking for the resultant force. So can. Okay, but then you need to tell them equal in magnitude 1,700. Okay, 1,700 meters is from the measurement. We need to measure this. Oh, then you convert with the scale. Okay, so this requires quite a number of practice. Okay, so for the purpose of today, sorry cannot let you try to get your hands a bit dirty. Okay, but I think there's definitely value in you doing this again. Okay, I want to move on to some calculations, then we'll have a short break before we move on to the next chapter. Okay, for question 7, we won't go through every single part, but what I want you to be breaking down and dissecting in this question is be super obsessed with certain words that you see in the question. Once you see constant speed, you should be like, whoa, jackpot already. Constant speed means acceleration 0. Acceleration 0 tells me, oh, resultant force 0. If I can tell myself resultant force is 0, after considering all the forces, the resultant force is 0. Therefore, if I push the bus forward, there must be something acting against me so that there is 0 resultant force. Can you tell me the friction in 10 seconds? Not much calculation involved here, in fact. Revealing the answer. we are pushing the entire bus forward with 17 kilonewtons. Kilo stands for times 10 to the power of 3 from chapter 1, right? Therefore, the friction must be equal 17 kilonewtons. So that resultant force equals 0. Okay? So be super obsessed with the constant speed days. Absolutely. Very good. Friction acting this way. Because what? Correct. Because we are just pushing it forward. Super good observation. Okay? Because it's not powered by energy. Alright. In part B, you start to get a bit challenging and you are linking a bit of kinematics here as well. Ooh, acceleration. Unsurprisingly, was 0.0000 until 17 seconds because resultant force is 0. But something happens. It starts to accelerate. Maybe like Incredible Hulk join them in pushing the bus along. More than friction happened. Pushing force is more than friction force. Resultant force is no longer 0. It starts to accelerate. Okay? 30 seconds for you to think about this. Can you make use of this value here? Can you make use of 20 kilonewtons? Can you find the resultant force first? Okay? If you are fast, you can go ahead to find the weight. Okay? But if you are still not sure as of now, try to find what the resultant force is when I have 20 kilonewtons pushing forward. Yes, got a question. By friction and force are the same, why is it? Oh, very good question. Okay, for the rest, you can continue to try first. Okay, but for those who don't understand why the bus can continue to move forward, right? Okay, because the bus is already moving. Okay, I wondered this a lot as a student as well, so I want to address this for you. Okay, friction and force, same. I know it cannot start the bus moving. So at the very start, they must have exerted a force slightly more than friction first. Then the bus starts moving, then the force equal to friction. Then the bus continue in constant speed. Okay. Okay, the first part should be done already. 20 kilonewtons, I am pushing. Resultant force what? Resultant force should be 3,000 newtons. Okay, so if you imagine it using a free body diagram, currently at this point, I'm pushing with 20 kilonewtons, friction is still the same, 17 kilonewtons backwards. Therefore, resultant friction has been found here, 17. Why is it? Friction will be the same for the same surface. Okay, so the resultant force must be 3,000 newtons in the forward direction. Acceleration is 1.5. I can then calculate x. Okay. W equals to mg. Weight therefore must be 20,000. That's mass 2,000 kg. Okay. Be obsessed with the approach, like I said. Okay, don't be obsessed with the correct exact answer here. Okay, because these exact values may not come out again. But if you know how to approach, you're good. Let's see, I shall leave it for you to view the answer key. Okay, I shall not run through this or discuss further on this. Okay, because we have discussed this based on Newton's third law of motion. Last question before we take a short break. Okay, this is an actual O-level question back in 2017 that was, I would say some students who don't understand inertia suffer. Okay, so velocity time graph, this one I won't dissect the graph together for you, but for kinematics people, whenever you have a velocity time graph, displacement time graph, always question yourself first. Gradient tells me what? Area under tells me what? Okay, keep questioning yourself that you are going to level up. Okay, but for this one, I want to discuss in terms of forces. If I hang a ball inside a car using a string, what are the forces that will act on the object or on the ball itself? Number one, something acting downwards confirmed is gravitational force or weight. Is the weight of the ball or the small mass? Sometimes people get confused with tension. Tension is very like unpredictable in the sense that nature, like sometimes tension acts this direction, sometimes in another direction. Exactly where the tension acts. Tension always acts away from the object. In this case, I hang a string, therefore the tension acts away from the mass arms. Okay, I want to talk about inertia here. The Newton's law of motion, I will leave it for now. Okay, if you have time, you can double back to this. Okay, but understand the inertia part first. How does the position of the mass change at t equals to 5 seconds when this occurs? T equals to 5 seconds is this portion here. At this point, the car is accelerating. When car accelerates, how will the ball swing? This is whether you can balance yourself on the MRT. If you don't get this question correct, most of the you are always falling over on it. Like you cannot like predict the inertia. Like, oh, you're like, oh, the other way around. This is related to Newton's first law. Always remember, inertia is about the object want to continue moving or the object don't want to move. Like your holiday homework like that. If you haven't started doing, it's super hard for you to start doing. But if you start doing, wow, then you're like, oh, okay, actually, then you finish it. Okay, that is inertia. So how is the ball going to behave here? I'll review the answer in 5 seconds. You should have a rough idea in your head, either forward or backward. Okay, or maybe stay still, I don't know. Correct answer is swing backward. Why? Because the ball doesn't want to move. For the exact explanation to part C, I'll leave you for the answer key. Allow me 2 more minutes before we have our break for part B. Okay, because this is applying 2 laws of motion. I think some of you may be a bit confused about the answer key for this. Okay, when the string is why the string is vertical, even though the car is moving at time t equals to 30 seconds. At this point here, surprisingly, the car is moving, but then the string like never move, like it's in the middle. But what we know from this is definitely acceleration 0. Again, link this to RF0. Oh, then jackpot already. Okay, but exactly what you need to know, you may understand the idea, but how do you apply Newton's law to explain? Okay, number 1, convince the examiner. You need to show off. Like, I studied that type already. I know velocity time graph, gradient 0 means acceleration 0. Tell the examiner, at time equal to 30, the car is moving with constant velocity. Constant velocity of 8 meters per second. This is what you quote data in the graph. Okay? To simply put this, when you all go to O levels eventually next year, right, Cambridge always needs to pay people to draw graphs, draw picture, draw everything. So if they like draw so nicely and put the numbers in for you, they expect you to move. Okay, so this is what I mean by quote data from the question. Okay, so the constant velocity, 8 meters per second, acceleration, 0. Get this straight first off. Okay, so that from here, you can apply Newton's laws. Newton's first law, just now we highlighted a few stuff. It will continue in its state of rest or uniform motion at constant speed, unless resultant force acts on it. Therefore, with 0 resultant force, it will continue in its state of rest. Okay, so how do I apply the Newton's first law here? Newton's first law, Newton's first law, mass will remain in its state because 0 resultant force, or some of you call net force, sure. Since acceleration is 0, so key things here, remain in its state, 0 resultant force, A equals to 0. Combining Newton's second law together as well. Newton's second law is nothing more than Rf equals to Newton's second law. Therefore, the mass will not accelerate. No acceleration, forces balanced, or resultant force 0. Yes, question. No difference. Resultant force and net force is the exact same thing. Thank you for your question. Okay. So you can use them interchangeably. Okay, for the rest, thanks for staying with me for 1 hour plus already. We have a short 1 minute break that I usually give to my students. Okay, there are snacks at the back that you can help yourself to. If I were you, I'll be like grabbing the gummies. Okay, but I don't know about you. Okay, so we have a short 1 minute break. We will come back very soon. Please rest your brain for a bit before we go into moment of the pause and pressure. Okay, deep part. Is the triangle okay? The triangle idea okay? No, huh? So it's the shifting of the force that disturbs you, is it? Like, why can I shift the forces? The whole thing in general. So the purpose of the skill pattern diagram, right, is to find out how the thing is going to either move or stay in that position. Like if I pull you up, then your friend pull you. Where are you gonna fly? Huh? Somewhere in the middle, right? Like, but if I use like super a lot of force, then you will fly a bit more towards me, but also somewhere in the middle. So that's the idea of resultant force. Right? Why do we draw parallelograms? Two forces acting like that. I want to find resultant force. Pull like that, go somewhere in the middle, depending on which one is the problem. All three at the same point. All three at the same point, you can use parallelogram. Okay, this one requires a bit more discussion. I discussed with you at another. Okay. Thanks, people, for taking your break. Yeah, I'm sorry that the break cannot be longer. I always feel very bad for everybody. Okay, but let's go again. Okay, turning effects of forces is one of the chapters that people will feel is easy, but end up unable to do. Okay, so the whole idea of this, you should imagine it as a seesaw, yes, but then will questions for pure physics keep it at a seesaw? Unfortunately, no. Okay, so usually combined physics and be like, oh, okay, I give you seesaw, you just lay up and down and then okay, fun. Okay, but pure physics wise, typically the questions look something like this. Yeah, okay, they give you things like this. What are the thing resting on the wall, force act here, act there, they want you to calculate. Okay, I'll give you the exact trick in a bit, but I'll show you some questions like this ladder resting on the wall again. Yeah, box, then I try to push the box over again. Okay. Then what helicopter, I want to try to pull up the whole helicopter, etc. Okay, so don't limit yourself to a seesaw going up and down. And the idea of moment of the force is indeed the seesaw. Okay, but as for students, you go home, if your parents ask you what you learn, you need to minimally be able to tell them, hey, I understand why the doorknob is always at the very end. Do you understand the idea? If you try to push the door, if you like try to push the door, nobody else see, right? You're gonna need a freaking big force in order to push the door. Okay, and if you understand what the movements is about, then you understand why. Why? Because the pivot is gonna the pivot is if I push the form across the pivot, the perpendicular distance is going to be short. If I push here, what the perpendicular distance is long. Very easy. Okay, so that's why your ball knob is always like at the opposite end of. Okay, so minimally you must understand this. Okay, so this brings me to the idea of what questions love to ask you is actually identifying the correct perpendicular distance. This is a super important idea. Okay? If we have time, right, later I will let you try this question where I'm trying to roll a barrel up a flight of stairs. Okay, it's not currently in your worksheet. Yeah, I keep this for my students. Okay, but what I want, if we have time, I'll let you try this. Okay, let's see. Okay, understand the basic idea behind this first. Moments, they love to ask definition questions. So either they might ask or define moment of a force. Usually, even for set force, they mix up moment of a force definition versus principle or principle of moments. Okay, so these two are different and their definition will definitely be different. Okay, so these two are pretty stark. Okay, I'll tell you exactly what people will mix up, or rather they forget to include in their answers. For moment, this one. Perpendicular distance is something people may forget. Apart from that, you cannot just write perpendicular distance times force. Not enough. Perpendicular distance to the pivot. Okay, so the whole formula here, right? I don't want you to write F times D anymore. Include this thing inside. Okay, it is for you to remind yourself that it is always perpendicular distance. Okay, from this formula here, moment equal to force times perpendicular distance, be able to pick out this idea already. And I'll let you try a question very, very soon, maybe in 1 minute's time or so. Perpendicular distance, as what we were discussing, if it's very large, what does it mean? If I want to generate the same amount of moment, I make sure perpendicular distance very large, F will be small. This is the whole idea behind the door pushing and everything. Okay, but question will give you a more chin start in that sense. Okay, so you must be able to identify the correct perpendicular distance. Principle of moments. Yes, because I use a very large perpendicular distance, when I push it very far from the pivot, all the way until then, so I push it as far as I can away from the pivot. Force. Okay, so units for this will be Newton meters. In moments questions, they love to give you in cm. Okay, they love to give you the distances in cm. Okay, so word of advice, yes, some of you are okay with the idea. If both sides cm, then I use cm, can what? Can. Okay, but if you are not careful enough, sometimes you may end up using cm to represent the final answer. Therefore, word of advice is change everything to meters. Okay. Principle of moments. This one, when they ask you for the definition, things that people will forget is this. I know a lot of you can tell me clockwise equals to anti-clockwise. Okay, so I don't really care. I'm not concerned. But some people will not say this. You need to tell me something, the object must be an equilibrium first. Clockwise, true, but you must tell me about any pivot. Equal to sum of anti-clockwise about the same pivot. So if you don't put this yellow color stuff that people tend to get, you won't get the full answer. It can happen too many times each. Two conditions for something to be in equilibrium, resultant force must be zero. This is something that people forget half the time. Without the moment zero, everybody can. This is just anti-clockwise equals to clockwise zero. Okay, but this should also tell you that sum of upward forces equals to sum of downward forces. If you are tested for turning effects of forces, I feel that questions are going to test you. Later we'll try one question. So downward force, whatever force is acting downwards. If you write Newton's you can. Okay. But advice is change to Newton. Okay, because sometimes you will be silent. Okay. But take note of the question a bit. Some questions may be more specific in express your answer in Newton meters. Okay, but in general, okay. Okay, so this is it. Before I jump to the CG and the stability portion, this is where I want you to try a particular question. Intentionally, I will start with question 5 for you to think about first. Okay, question 5 is super important. If you can understand this idea, your identification of perpendicular distance is strong. Okay, give yourself 30 to 40 seconds if you need to try this. 10 seconds. No calculation required, but you need to be super clear on a certain concept. Okay, I review the answer first. Answer may surprise some of you. Answer is D. Okay, so I think the bigger struggle might be A versus D. Okay, so let's explore why A is actually like almost correct but not correct. Okay, let's sorry. A was correct. Okay, I'll say so now. For B and C, I need to be able to eliminate first because option C, the perpendicular distance, is right here. I know this will not be as long as this perpendicular distance because Pythagoras theorem. Right? So this one eliminate. So good. This one even worse. This force over here, how can I find perpendicular distance? If I pull an object in this way, I am trying to pivot about this point and try to topple the block. What is going to be my perpendicular distance? Here. This is my perpendicular distance. The orange color line. That's why B is out of step. Recall what we were just saying. So I will want to make my force small, I need my perpendicular distance to be large. Therefore, I'm trying to find the largest perpendicular distance possible. Okay, reason why A was almost correct is for A, yes, the perpendicular distance you may be seeing as this dotted line over here. Okay, but how am I trying to topple this entire block when I pull it this way is here. I am trying to pivot about this orange color point. So it is actually not this dotted line that we are trying to, it is not this dotted line that is the perpendicular distance, but it is this orange color line that I will be drawing in to be the perpendicular distance. You see?
Why is it
Trick. Because of where the pivot is. When I'm trying to pull this way, I need to pivot about this point to topple the block. Okay?
Oh, sorry, that's how it looks.
Correct. Exactly. Very nice. Okay, using your phone. Okay. So what I need to do in questions, when you want to identify the correct perpendicular distance, you can continue to extend the force as long as you want. Extend until you shook already, then you make sure you can draw a perpendicular line from the force to the pivot. I extend, I make sure I can draw this line. Then for this one here, can you see why this is the largest already? This one I am pivot about this point.
Oh, where's the other?
Correct. So my perpendicular distance is just the dotted line given to me, which is the largest. Because I don't need to, I can extend. But I already can draw a perpendicular line. So I don't need to extend in this case. Okay, so question 5 is this. So be able to identify the correct perpendicular distance. I won't have you try all the MCQs, okay, but what I need you to know is this kind. Okay, like I said, it's not always a seesaw. So if question gives you things like this, you give yourself 1 minute to identify question 1, to try to solve question 1. Okay, but dissecting of the questions wise, take note where the pivot is going to be, pivoted T. Pivot is going to be at this green color dot here. Pivot is super important so that you can identify the correct perpendicular distance. In this case, I'm trying to support the core, so everything must be in equilibrium. Things that you should be thinking, clockwise equals to anti-clockwise. Can I solve this question? Okay. After breaking down the question and this, right? 45 seconds, we try to solve this. Run out, guys. Gosh. Thirty seconds left. Tell you guys. 15. How can you identify? Hmm? I learned before. Oh, you still haven't learned? Oh, okay. So first I finish dynamics. So you have tested on kinematics. The WA1 test one. The WA1 test one. Line. Okay, so your school is another strange one. Start on waves first. Got do thermal physics. Oh yeah. Kinetic dynamics not tested. Okay. But you'll be tested for OLED. The vector diagram. You've done second part. Okay, then you are one step ahead of the peer count. Okay, now, correct answer, I review first. I will show you the exact working that I want you to do. Option B is the correct answer. Okay, if you have identified clockwise, you go to anti-clockwise. I think the most important thing is, can you tell me whether it is causing clockwise or anti-clockwise moments? Okay, so the 100 Newton force here is pushing this way to the left. You must be able to tell me whether it is causing clockwise or anti-clockwise. If you struggle with things like that, always use a pen to your advantage. Everyone got pen. Okay, so you hold the entire thing in front of you. Hold in front of you. I think I turn around. I think be able to see better. Right? Okay, the entire thing is here. If the pivot is here, and I pull it this way, my 100 Newton force is acting to the left, right? I'm like pulling it this way. How is the entire thing turning? Clockwise. The force F. Same thing, the whole thing in this way. Force F is pushing upwards this way. How is it turning? Anti-clockwise. Okay, so if you always cannot imagine clockwise and clockwise, right? Use a pen. Okay, I always advise students, but end up exam, they just like the whole diagram in the head, then try to imagine. Then end up will just okay, so I can only advise you. Okay, then end up in class, then you will do it. Okay, so if you really cannot see, then make use of this. Okay, but good, correct. So the 100 Newton is causing clockwise movement. So 100 multiplied by the perpendicular distance. Okay, if you use 70 cm, then you will be in trouble. Okay, because it is not the perpendicular distance. Perpendicular distance will be I extend this further. I extend this as long as I want. You want to extend to the end of the page, sure. Okay, but you always extend until you can draw a perpendicular line to the pivot. Therefore, it's 35. Okay, but 35 cm, if I use on both sides, sure. So my word of advice is still convert to meters. Correct. Correct. Pivot must be perpendicular to the force. Okay. Anti-clockwise moment will therefore be force F multiplied by 80 cm. Okay. Again, this one I don't really have to draw, but I can extend and see that this is the perpendicular distance, 80 cm. Done. Okay, with this, I just do a bit of that, and solve for F. The biggest mistake here might be using 70 cm. Okay, I won't have to try question 2. I want to talk a little bit about stability and CG, then we will go already. Okay. If I can jump back to the CG and stability a little, CG center of gravity, remember, one page before, this must be the entire weight appears to act. This is on page 34. One page before. Okay. So definition wise, CG sometimes will ask, so know that it is the appear to act, because in a ring, where can the CG be? It can be in the middle, like floating. So the CG doesn't need to be on the object itself. Okay, stability wise, stable, unstable, and neutral equilibrium. How question will expect you to be explaining your answer will always be whether the line of action of the CG is within or outside of the base area. For stable equilibrium, I like to take it as SUN. S stands for Superman. Superman, no matter how we push him down, he gets back. This is Superman. This is stable equilibrium. U stands for useless. This fella, you push him a bit, fall down, topples over. Key things that question will require you to write. Line of action of CG falls outside the base area. Okay. When it falls within base area, you need to tell generates a moment. Generate a moment, don't be too like happy with this because you need to quote direction. Tell the examiner exactly clockwise or anti-clockwise moment. Which one? Okay, same thing for unstable equilibrium. I generate a moment. Same thing, you must tell the examiner clockwise or anti-clockwise. This really depends on the question. So there's no correct answer that I can give you here. Okay, but this one is, you can think of it as useless. Push it a bit forward. This guy is napping. Basically, if I nap on the floor, then you're like try to roll me around. My position or my center of gravity doesn't change. I will just be rolled. Okay, so what happens is line of action of CG passes through the pivot. This is neutral equilibrium. Give quick 5 seconds for me to show you this sumo so that you'll remember this forever. Okay, sumo match like this. Okay, like opposite showing you all like half naked guys like fighting each other. But the point is, how do they always fight? They always going this way and this way. Why? Can you see a small wrestler going this way? They don't. Why? Because they need to make sure they are stable. Okay, so to increase the stability, they always go low. They always go low in order to do what? Lower CG. That's like if you stand on the bus, you want to like be super stable, then you can do this stuff. Okay, but you're probably look like an idiot by doing this. Okay, you cover one fall already. Okay, then can lower your CG. You can lower your CG as well as increase your base area. Okay, so they always stand like shoulder width apart so that they can become stable as well. So increase base area. They also won't go in on that. Okay, so the sumo is a very good example for you to think about increase base. Amount of force acting on the object, like to topple the thing over, it will, because it will generate a larger moment in that sense. If you what again? To see whether stable or unstable, the only way to see is whether it lies within or outside the base area. So in that sense, you don't need to care about force. You see whether the CG lies inside or outside the base area. For this one, we can see that the CG, when you tilt it over, right? When you tilt it over, you look something like this. The CG is still acting inside the base area. For this one, you tilt over, the CG lies outside the base area. So in that sense, no matter what the force, it will be unstable. Super good question. What do the diagrams mean? On how they are positioned? What do you mean what they mean? So the stable equilibrium will be the base is resting on a bigger base. Then the unstable is resting on a smaller base. The center of gravity is here. For all of it is somewhere in the middle, but they are resting on different base areas. Okay, so you can see the smaller the base area, the less stable it is. Okay. Smaller base area, less stable. So just a quick one for us to see. I think question 4 was sum up. Okay, which one will be the most stable? Just a quick 5 seconds for you to think about this. I think this should be okay. Oh, no. So the base area will be this entire thing. When I stand like that, my base area is this. Okay, I think we are good with this. Answer should either be A or D. Okay, so you should see the lower CG, therefore answer is A. Okay. Okay, one question to sum up moments, question 6. Okay, the rest can look at the answer key and try the questions out when you are back at home. Okay, but question 6 here is something I want to address for this particular question. Okay, you can pick up the forces that are acting first. This entire system of a pole water, there is a weight of the pole, there is a D downward force, there is a U upward force. Questions like that where there is no pivot for you, what can you do? Don't care. Establish a pivot on your own. Okay? So a pivot needs to be supported by a force, therefore it must be either D or U. Okay, so it's going to be common. Questions like this you might face. Will there be always a pivot for you like a nice triangle thing? Not necessary. Okay, so when there isn't, choose one on your own and tell the examiner the following. Taking moments about D. This is telling the examiner that I am establishing the pivot exactly at point D. Okay, give yourself 1 minute to try this. Now that we have established the pivot at point D, can you try to calculate the force of U? You should become comfortable with this if you have understood what we were discussing. For moment equals to force times perpendicular distance. Thirty seconds. Ten seconds. You should have established which direction they are actually causing a moment, whether you use imagination or you use the plan in front of you to push. Okay, fix the pivot, then you push, fix the pivot, then you push. We should be able to see clockwise or anti-clockwise. Okay, so whatever it is, we have the perpendicular distance. You should be able to find it pretty straightforwardly. Okay, but my trouble is the second portion. So U should be equal to 231 newtons. We good with this?
Yeah.
Okay, so in your schools, you most likely rounded it off to 230 newtons to 2SF. If you put to 2SF, it's fine. Why? Lowest SF, right? The school always emphasize.
Anything else we want to
Anything 3SF. Okay, I tell you the truth. In O levels, it is either 2 or 3SF. What most schools teach is what practical we expect you to do, lowest SF. So for those who have lowest SF, for 2SF, perfectly okay. Stick to what your school says because WA will be marked according to your school. But next year I'll tell you what it is. Because I don't care about your school, I care about your list. Okay, so for U equal to 231 newtons, I want you to be thinking on two methods to solve for D. I can solve for D using two different methods to get 131 newtons. Okay, what is a super straightforward method to think about? Hence, it's one condition for an object to be in equilibrium. Yeah. So the weight is causing clockwise, U is causing anti-clockwise. My pivot is at T. Because I established it to be there. Because I have no triangle nice pivot that is given to me in the question. The direction of the moment generated by force. So you can use your pen to see for yourself. Okay. So two methods that you can use. Option one, if you have thought about this, you can establish the pivot at U. If you establish the pivot at U, then you can see, oh, D is going to generate an anti-clockwise moment. Weight is going to generate clockwise moments. Sure, we can calculate. Okay, a more straightforward method is sum of upward equals to sum of downward. Therefore, the weight 100 plus D equals to U. That's why D can be calculated 231 minus 100 equals to 131. Okay, so the answer key that will be given to you establishes U as the pivot. Okay, but the alternate method that I want you to think about is sum of upward equals sum of downward forces. Okay. So I think if you are tested for this for WA, most likely a similar question like this will come up. Okay. And for the sake of your WA, I feel if they don't test this kind of whole board questions, what can they test? Give you a beam. Give you a beam, tie two strings. Then ask you to calculate the tension in here, tension T1, tension T2. Okay? If there's such question, same thing, use the exact same approach. There will be the weight that's acting maybe in the middle if the beam is uniform. Okay, so what do you do with questions like this is there is no nice pivot for me, therefore I establish a pivot for myself. Tell the examiner, oh, taking moments about T1. Then I try to find clockwise equal to anti-clockwise and so on. Okay. And that's for moments that I will be covering. Okay, the last 10 to 15 minutes will be about pressure. Okay. Yes, I wish I could have more time to cover more questions. Okay. But can I just give you a final word of advice for moments that when you see uniform, you need to tell yourself CG in the middle, center of gravity. Okay, so it acts directly in the middle of the object. So don't forget to include that in when you calculate moments. Okay, so just one final one before we move on to the question. I need you to be able to tell me this. The force acting on the ladder here, pivot is here. What is the perpendicular distance that I will use? Is it 1 meter or is it 4 meters? If I want to calculate moment generated by force F, be able to convince yourself this. Is it 1 or 4 meters? It started from here. Or is it this? I need to use Pythagoras theorem. It's quite common out that physics need to use Pythagoras theorem. 1 meter is not correct. Okay. So this one, I'm glad I addressed this. Okay, so again, what you need to do? I told you you can just extend the line as long as you want. You want to extend to the end of the page, feel free. Extend until a point where you can draw a perpendicular line down to the pivot. This is the perpendicular line. Therefore, your perpendicular distance must be 4 meters. Okay, super common error. So if you use the wrong one, then you won't be able to solve it, even though you know every single shape. Okay, what's the CG? The CG here is here. Okay, directly in the middle of the line. Because of forces, the weight must be always acting downwards. Okay, what is the perpendicular distance from the weight to the pivot? Perpendicular distance from the weight to the pivot. How do I find the correct perpendicular distance? Good question. You always extend the force, then you draw a perpendicular line to the pivot. That will be the perpendicular distance. Okay, 0. Correct answer? 0.5 meters. Half of this. Okay, so again, you can extend this line, extend. This is my perpendicular distance. Okay, if not, I really should move on to pressure. Okay, sorry to those who are waiting for pressure. Okay, but I will tell you exactly the common mistakes that people make and what I feel your test will be testing well about. Okay, so sorry, I have to go on to page 42. Okay, content-wise, gonna spend around 5 minutes. Gonna have you try some questions and dissect some questions for common mistakes. Okay, for pressure-wise, pressure equals to force over area, you all learn this inside. Okay, so I won't jump into this again, but the most common thing that people do is units. Area, meter square. Okay, so sometimes they'll give you in cm. Pressure in fluids. Okay, for those who haven't learned this topic, you might find this a little bit fast. Okay, but for those who have learned this, I need you to be able to confidently tell yourself that this is a result of pressure equals to force over area. Why? Pressure equals to force over area. The force exerted is the weight of the fluid, therefore equals to mg. W equals to mg. It is the weight exerting downwards. How can I calculate mass using density and volume? Density times volume. When I have a container, a cylinder, how can I calculate volume? Area times height. Which I don't know how to calculate. Then volume equals to area times height. Therefore, volume over area gives you height. Therefore, rho hg. So this is a result of pressure equals to force over area. Okay, pressure won't force you to prove this. Okay, but if you can tell yourself this comfortably, your understanding of P equals to rho gh will let off. P, here, whatever we have done here, from force over area, mg, V over A, because density times volume equals to mass. So I simplify this. This one don't require you to know the proving, okay, but if you can tell yourself that this came about because of force over area, then rho gh will become very intuitive for you. Okay, I run through the important stuff. Okay, so for this atmospheric pressure, they love to ask this. Atmospheric pressure, you need to understand as air pressing down on us. Are we experiencing atmospheric pressure right now? Yes, air is pressing down on us. We go up to the mountain, what happens? I go up to the mountain, I try to run. I thought I very fit, lift all. Run, then I run 400 meters out of breath. Why? Air is thinner. Air above, when I go mountain, is always thinner, therefore atmospheric pressure smaller. Okay, so atmospheric pressure will be smaller at higher altitudes. Okay. Sorry, to go back to the rho gh, one of the misconceptions that people will have is this. This is the point where I can use P equals to rho gh. If question asks me for a point that is in the middle, here. If it's in the middle, do I still use rho gh instead of h? In the middle, there is only half the height of the liquid acting. So if I want to calculate pressure at this point, it's rho g h over 2. it will be half the height. Okay, so the pressure needs to be, you need to be sure that it acts at every single point. Okay, next will be some test. Yeah, test here for hydraulic system. Okay, hydraulic system, a quick one. If you all see, like you all go to here, then you all see they need to like push the carts around, then you need to like press this, and then they like push the thing around. This is hydraulic system. Okay, and exactly what they are doing is trying to lift something super heavy. Okay, and this stems from your set 2 concept. If I understand pressure equals to force over area, what I will be able to establish here is pressure equals to force over area. F1 over A1. Okay, humans are super weak and lazy. Therefore, we can only exert a very small force. If I exert a very small force, I need to ensure that my area is small so that my pressure can be large. This pressure is going to be constant throughout and reach here with the same amount of pressure. If I want to exert a large force, force equals to pressure times area. If I want a large force, I need to ensure that my area is also large. This is the whole idea behind hydraulics. The last part to this is the competition between two parts. In mercury barometer, yes, I need to talk about this a little. When atmospheric pressure acts on the surface, there will be a height that is established here. This height is going to be atmospheric pressure. Therefore, when I have a mercury barometer, the height of the mercury gives me the atmospheric pressure. Take note that vacuum, when you eventually learn this thing may not be said, I feel, because they treat it as you understand. But vacuum does nothing. Therefore, it doesn't exert any downward force. Things that question might potentially ask you is if I have a crack and air enters, what happens? When air enters, it is no longer a vacuum. What can the air do? Press down on the mercury column. When air enters, I expect my mercury to become shorter. Okay, so this is a situation where mercury barometer cracks. Okay. In your head, when I bring this mercury barometer up to the mountains, what do you expect this to happen? Height will become smaller as well. Okay, so the entire thing comes from rho gh. The rho is the symbol for density. Okay. Last one. This YouTube manometer thing is commonly mixed up by a lot of people. So for those who are tested for WA2 especially, okay, if you hate this shit up, you need to tell yourself, whenever I have YouTube manometer, it's always a competition between who? Between both sides. In this case, it is PATM versus my gas pressure. If you and your friend are like pressing down on this liquid together, what happens? This height becomes higher. What does this mean? If your friend is on the right side, your friend managed to press harder than you, so that this height is higher. Therefore, always question yourself, who won this competition first? Who won this? Oh, P gas won. If P gas won, P gas is going to be larger than PATM. Larger by how much? Larger by this height. Okay. So this formula here, don't bother. Straight up tell you don't bother because you need to decide who wins first. Then you can have a good decision on whether you add or subtract. Because P gas won, that's why I add the rho gh. If I have another manometer that looks like this. Drawing us. I literally just need to copy this. If I have another manometer that looks like this, who won? PATM or the gas? In this case, PATM. So in this case, to calculate pressure of gas, I need to use PATM minus rho GH. That's why I told you don't. That's why I tell you don't bother about this formula. Okay, because there's no way for you to like memorize this. Okay, because you need to react to different situations. Okay. All right. Okay. The last one here I shall not run through. Okay, this is the very common thing we like to ask. Okay, I shall dissect a question for us to think about together. Most of the MCQs will be fine, except this one. Okay, think about question 4 for this. Okay, we'll think about 2 more questions before we sum up. Okay, think about question 4. It's tricky. You need to remember that vacuum does nothing. Okay, so I have a open-ended. Open-ended always means I have atmospheric pressure exerting. Vacuum does nothing. You can think about who won. In an open-ended manometer, won. The 30 more seconds. Okay. Okay. Dissection of the question is important. Okay. If you ask yourself who won, you are already one step there already. Okay. So who won in this case? PATM or gas? P gas won. Because it pushed down more than PATM. So then this level is higher on the other side. So P gas will be equals to PATM plus 100 mm of mercury. Therefore, 760 plus 100, 860 mm Hg. And this is the answer. Why? Because when I put it here, vacuum does nothing. Gas pressure is the only thing that is pushing the mercury. Therefore, this height over here must be whatever that the gas pushed, which is 860 mm Hg. Okay? Because there's no competition here. This is P gas against this. Okay. Okay, just one final one to sum up for question 1. Okay, we jump back to question 1. Understand how PATM is going to change when I move to mountain. Okay, this one should be around 15 to 20 seconds, I get the answer. And we'll sum up on this. Again, vacuum does nothing. And time. Correct. Which have answer? Should get it. Option A. Okay, when I go up to mountain, atmospheric pressure decreases.
Why?
Because the air is thinner. Okay? So with PATM acting at this point, this is PATM against himself once again. So if PATM becomes smaller, I should expect this to become shorter. Because at the end of the day, pressure equals to rho G. To link this to chemistry as well, why are we with this? Why are we writing Hg, Hg, Hg? Hg is the symbol for mercury. That's why just now we wrote like MMHG, CMHG. Okay, if not, we'll wrap up here. For dynamics, I chose to spend the most time there because I feel you may need the most time there. And I feel the weightage of your paper-wise, dynamics should be the largest. Okay, terminal velocity, need to understand. Okay, vector diagram, need to be able to draw. Principle of moments, you need to know perpendicular distance identification. If you have these things ready in your bank, you should be good to go for WK. Yeah, I don't know where your respective WAs is where fixed. Okay, but I hope this will be comprehensive enough. And for answer key, it is actually here. For people online, it's actually here. Okay, you can scan to have the answer key. For people here, I will be printing the answer key for you. So after the press print, but I don't know how many people. Okay, I press print again. While printing, can you help me to fill in this feedback form? Can you help me to scan this QR code? When you finish the survey, I can give you some periodic table thing. By the way, do you all need this? Anyone think I would? You people say one is.
Yes.
Do you want the physics one?
Moments.
Anybody take physics?
You buy
Yes, I know.
everybody on
I thought the next.
virus.
Can I ask one? Okay. Hey, but can you help me fill in this, please? Help me fill in this. My name is Gerald. It's like, yeah, select from the drop down. Sorry to keep your parents are waiting for you. Online people help me fill in too. Answer QR code one more time. Oh, okay. Wait, I let people scan finish this one first. Scan. Everybody, please help me to do this. You can give any feedback. I think there's a part you can like free response. If you judge your red task, zero thing. But I don't know.
Wow.
Yeah, sure. People online don't leave yet if you haven't. Anybody interested to take a picture together? On and on. Okay, here is the QR code for answers. Elson, you got in 5 seconds. Là nó cũng về chơi có số mấy cái trường hợp nó là online là cái okay. No problem. Elson, no problem. Okay, for those who haven't done this, please help me to scan this and fill in the page.
Rồi. Sống đâu? Con
Sáng nay bao lâu cũng sẽ có thể phải pass.
I'm giving like this. I don't go to mall thing. Well, that thing. I do what? On the side. not really speaking. Is she gonna die?
Okay, thank you everybody for being part of this journey. Okay, I hope these 2 hours has been great for everybody. Okay, because I know schools, I know how little schools teach. Can we take a picture together? Sure. Standard practice. Okay, the genes dominate. Okay, come.
It's very easy.
Hey everyone. Please let me take more of it because my one hands. Okay, trigger. Is it very important? Me. They have it a few more. I don't like a mile. Okay. Congrats for WAs. You're around. Bye.
Try not
Email.
to find my person to real hand.
Don't have it. Don't have it.